Okay, so in the last lesson, we finally really dove into the endocrine system. We talked about how the hypothalamus is kind of in control of a lot of the different things happening with the endocrine system. And we specifically looked at its control over the endocrine glands. No, yeah, the pituitary glands. So today we're going to be talking about the next endocrine gland, the thyroid gland, which you might recall we mentioned in the previous lesson because it is stimulated by thyroid stimulating hormone from the anterior pituitary. But today we're going to go more in depth into the thyroid's hormones and how it works. So for the thyroid gland, we're essentially going to go over what the thyroid gland does, where we can find it, what its hormones are, how those hormones are stimulated, what those hormones do, what happens if you have too much or too little of the thyroid hormones. We're also going to talk about the parathyroid glands, which are on top of the thyroid glands, and what their hormones are. And then we're going to talk about how hormones from both the thyroid gland and the parathyroid glands help to regulate blood calcium level. So the thyroid gland is the gland of the endocrine system located at the base of the neck in front of the trachea. It produces and excretes thyroxine, also called T4, and triiodothyronine, which is also called T3. Both of these hormones help to regulate your metabolism, as well as have some role in the growth and differentiation of tissues. The thyroid also produces another hormone called calcitonin, which acts on the bones to lower your blood calcium levels. So we'll start talking about T3 and T4. About 65% of the thyroid gland secretions are T4, so it is the #1 hormone produced by the thyroid gland. The secretion of both T4 and T3 is regulated by thyroid stimulating hormone. So you start off with the hypothalamus releasing thyroid releasing hormone. That goes to the anterior pituitary, stimulates the anterior pituitary to release thyroid stimulating hormone. Thyroid stimulating hormone goes to the thyroid and causes it to release T3 and T4. And then this is, of course, controlled by a negative feedback loop, like with most hormones. So as T3 and T4 build up in the blood, that actually goes back and stops the release of thyroid stimulating hormone from the anterior pituitary. So yeah, that's just kind of the negative feedback loop. So again, step 1, the hypothalamus sends thyroid releasing hormone to the anterior pituitary. The anterior pituitary sends thyroid stimulating hormone to the thyroid. It's going to release T4 as well as T3, which will go back and cut off the production of and release of thyroid stimulating hormone. Like I said, both T3 and T4 have to do with metabolism, so they increase the rate at which your cells kind of burn through sugar. T4 specifically increases the rate of fat, carb, and protein metabolism in order to use that for energy. T4 targets the heart, skeletal muscle, liver, and kidneys as well in order to increase their rates of cellular respiration so that they're using more energy. T4 also helps with the differentiation of cells into tissues and organs, which is important when children are growing and developing. And then T3 increases the basal metabolic rate, which is just kind of the minimum amount of energy that an individual needs when they're at rest. So by the way, because T4 causes fats, proteins, and carbs to be metabolized faster, that does mean that you'll have a buildup of like sugars and amino acids and fatty acids and stuff like that. All of the byproducts of broken down fats, proteins, and carbs, their levels will increase because of T3 or because of T4. Okay, some people do have abnormal levels of these thyroid hormones. Sometimes it's just, you know, a slight difference. So someone with like a slightly high level of thyroxine might burn through sugars and store less fat than the average person. They would have difficulty gaining weight. They would feel warm all of the time. People who have slightly low levels of these thyroid hormones might feel a little weak. They might be cold all the time. They might have really dry skin, but none of those are like big issues. They're just like, slightly different from average, but it's nothing to, go to emerge about. There are, however, some serious conditions that affect the thyroid gland if your levels are way off from normal. So those include hypothyroidism, hyperthyroidism, and goiters. So hypothyroidism is when you have too little T4 being produced or secreted by the thyroid gland. That's going to result in a much lower metabolic rate. The heart rate will be slow. That person's skin will be really puffy. They'll be really tired all the time, very like apathetic, like everything is just like meh. Nothing's really exciting, and they tend to gain a lot of weight. You can also have something called goiters if T4 levels are super low. That actually tends to happen because of a lack of iodine in the diet. So T4 molecules require 4 iodine in order to be made. There are 4 iodine atoms in every T4. And so if you don't have enough iodine in your diet, the thyroid just can't make T4. So your T4 levels will drop. And because of that, your anterior pituitary will keep releasing thyroid stimulating hormone because it wants the thyroid to make T4. However, the thyroid is just like, stop coming at me, bro. I can't make the T4. I don't have any iodine. And the thyroid stimulating hormone is just like, make it, make it, make it, make it. And it's like, I can't. And so because of all this constant like poking and aggravation by the thyroid stimulating hormone on the thyroid gets this big bulge in it that you actually see on the outside of the neck. It's this big bulge, and that's called the goiter. And it's essentially just the thyroid becoming enlarged because it's constantly being provoked by the thyroid stimulating hormone, and it just can't make the hormone. It can't make the T4. Goiters are very rare in developed countries nowadays, though, because back in the 1920s, they started adding iodine to table salt. And nowadays, like all of your table salt will be like iodized table salt. Lots of processed foods also contain iodine. So nowadays, people tend to have lots of iodine in their diet. But back before iodine was added to salt, goiters were a much more common problem. Ooh, it's growing. Okay. Then there's hyperthyroidism, which is the opposite of hypothyroidism. This is when too much T4 is being secreted by the thyroid. This person will have a really high metabolic rate. They'll have a lot of weight loss, will have a really difficult time maintaining their weight. Their heartbeat can be really irregular. Their blood pressure is really high. They tend to feel anxious all of the time, not be able to sleep. They're always hot, always sweating. The muscles around their eyes actually like swell and put pressure on the eye and cause the eye to bulge like out of their head, which can affect their vision. And a very severe form of hyperthyroidism caused by the body actually attacking the thyroid, it's a form of an autoimmune disease, is Graves' disease. Hyperthyroidism can be treated with medication, and in severe cases might require the removal of part of the thyroid. This is kind of what a normal person's eyeball would look like compared to the eye of someone with hyperthyroidism where it's bulgy. Okay, so that is it for like T3 and T4, which again are released when thyroid stimulating hormone stimulates the thyroid and they regulate metabolism. Calcitonin is also produced and secreted by the thyroid. However, in this case, it's not controlled by the thyroid stimulating hormone. It's actually not controlled by the hypothalamus at all. Instead, if there's too much calcium in the blood, that is going to directly stimulate the thyroid. The thyroid will then release the calcitonin. And what calcitonin does is, one of the things it does is it starts to essentially put calcium onto your bones. So it kind of like builds your bones up with that extra calcium. It's going to also cause your kidneys to stop reabsorbing as much calcium and just like pee out some of that calcium. And same with the intestines. It's going to say to the intestines, stop absorbing so much calcium, let's just poop this out. If calcium levels then drop, the calcitonin secretion will be stopped, and that's done by the parathyroid gland. So the parathyroid gland is actually 4 small glands attached to the front of the thyroid, and they also respond directly to chemical changes in their environment. So they're not controlled by the hypothalamus either. In this case, it is just going to be low blood calcium directly stimulating the parathyroid gland. And when the parathyroid gland is stimulated, it releases parathyroid hormone, or PTH. The PTH is going to inhibit the calcitonin, so it'll stop the calcitonin from being released from the thyroid. And it's also going to actually start breaking down your bones to release some of that calcium into the blood. It'll also cause your kidneys and your intestines to reabsorb more calcium. So this whole like butterfly shaped thing is your thyroid gland, and then these 4 little circles are the parathyroid glands. And again, if you have like high blood calcium levels, that's going to cause your thyroid to release calcitonin. The calcitonin is then going to stop your kidneys from reabsorbing as much calcium, stop your intestines from absorbing as much calcium, and cause calcium to be deposited on your bones, which will then lower the blood calcium levels. If blood calcium levels get too low, that will stimulate the parathyroid glands. They will release parathyroid hormone, which will go and cut off the calcitonin, will also cause your intestines to absorb more calcium, your kidney to reabsorb more calcium, and your bones to actually be broken down to release calcium. All of those things will increase your blood calcium levels again. When a nuclear power plant explodes, it does release a lot of radioactive iodine, and iodine is always very quickly taken up by the thyroid gland. And so if radioactive iodine is taken up by the thyroid gland, it can be very concentrated in there, which can then cause things like thyroid cancer. So people who live or work near nuclear power plants are instructed to keep iodine pills on them, or like in their desk or like somewhere nearby, so that if there's a nuclear accident, they can pop a couple iodine pills. Their thyroid will suck up all of that iodine, and then the idea is that your thyroid will then be full of iodine, so it doesn't have room to absorb any of the radioactive iodine, and thus it protects you from that kind of thyroid cancer. When I was in Ontario, I spent 10 weeks working at a school that was near a power plant, and we actually did like drills where you like pretended to like hand out iodine pills to all the students, and you had to like know where they were in your desk and stuff. But obviously never had to use it, thankfully. Nuclear power plant explosions are incredibly rare. Okay, I am going to flip back over to our giant flow chart now for a second. Okay, so this is kind of the section that we're focusing on today, and I will zoom in on this in a second. So we'll start by talking about the T3 and T4 from the thyroid. So that does start with the hypothalamus. The hypothalamus is going to release the thyroid releasing hormone, which goes to the anterior pituitary. That stimulates the anterior pituitary to release the thyroid stimulating hormone, which then goes to the thyroid. Now let's zoom in on the thyroid here for a second. And sorry, let me just get that into focus. That's probably as good as I can get. Okay. So the thyroid, once stimulated by the thyroid stimulating hormone, the thyroid will release T3 and T4. T3 is going to increase the basal metabolic rate, which again is just the amount of energy that a person needs when they're at rest, not doing anything. T4 is going to increase cellular respiration. It's also going to increase the metabolism of fats, carbs, and proteins, which means you're going to have a buildup of like fatty acids, sugars, and amino acids in your blood. And then the other job of the thyroid is when it's stimulated by a high blood calcium level, the thyroid is going to release calcitonin. Calcitonin goes to the kidneys, causes them to decrease their calcium ion reabsorption, also goes to the intestines and tells them to absorb less, and it causes more calcium to be deposited on the bones, all of which lowers the blood calcium level. Now, if the blood calcium level gets too low, that low blood calcium level is going to stimulate the parathyroid glands to release parathyroid hormone. Parathyroid hormone is going to inhibit calcitonin, so stop it from working. Parathyroid hormone is also going to go to the bones and cause them to break down to release calcium ions. It'll go to the intestines and cause them to absorb more calcium ions. And it will go to the kidney and cause them to reabsorb more calcium ions, all of which increase blood calcium levels. Okay, that is it for the thyroid and parathyroid glands. Don't feel like, again, that you need to have all of these flowcharts connected. You could very easily have like this sketched out and then just have like above the thyroid, you know, an arrow going to the anterior pituitary with the TSH coming and then to the hypothalamus. Okay. Yeah, anyway, let me know if you have any questions about this stuff.